The world's largest tunnel boring machine came to a sudden stop after digging just 1,000 feet into a tunnel that was planned to stretch nearly 10,000 feet. The event caught everyone's attention because it showed once again how far China has come in developing technology that seems to challenge the limits of physics. Over the last few decades, China has built roads, bridges, schools, and entire cities at an unbelievable pace. Their massive bridges make famous ones like the George Washington Bridge look small in comparison, and these incredible structures can be found all over the country. China's giant machines complete enormous construction tasks faster, cheaper, and more efficiently than anyone thought possible. Without making much noise about it, China has taken the lead in global mega construction. Today, an amazing number of the world's largest engineering projects depend on Chinese technology. At the start of the 2000s, China had no share in the global tunnel boring machine market. The West had been improving this technology for over 150 years, and experts thought it was too advanced for newcomers to catch up. Yet by 2024, everything had changed. China had taken control of the market, providing machines for almost every major tunneling project around the world. While California struggled for 16 years and spent billions trying to build a single high-speed rail line, China built more than 40,000 kilometers of track during the same period. Their network included tunnels, bridges, and viaducts connecting huge cities as if they were pieces of a massive Lego set. China didn't just build fast, it turned speed itself into a national strategy. Things that seemed impossible in other countries became normal in China. The secret behind this success was China's ability to focus its entire national effort on solving major challenges. Instead of spreading research across separate companies and universities, China united its government, industries, and workers under one mission. They imported foreign machines, took them apart to study every detail, rebuilt them, and then began producing their own versions at scale. The process wasn't slow evolution, it was pure acceleration. Where the West advanced gradually through trial and error, China cut away the delays and worked as if the entire process was running on fast forward. What took other nations more than a century to develop, China achieved in just 20 years. This was not luck but careful planning. By synchronizing universities, industries, and supply chains, China built an extremely fast learning curve that no one else could match. Behind these machines stands a powerful human force, millions of engineers trained with discipline and determination. China's biggest strength isn't only its technology but its people. While many Western countries discuss work-life balance, China has created the largest engineering education system in the world. Millions of students are enrolled in more than 23,000 engineering programs, forming a massive workforce dedicated to innovation and infrastructure. Every year, China produces about 1.5 million engineers, around one-third of the global total, while the United States produces less than a quarter of that number. So when people ask how China can build 10 high-speed rail lines while the West struggles with one, the answer is clear: they simply have the people and the structure to do it. In the West, construction often stops for weekends, holidays, or bad weather. In China, construction is treated like a campaign that never rests. Workers operate in 3 continuous shifts, working day and night, 7 days a week, through any condition. The machines keep running, and so do their operators. At midnight, you can find giant tunnel boring machines still grinding through rock. One team finishes their shift, another takes over, and a third prepares behind them. It's not chaotic, it's a perfectly timed system, rehearsed from classrooms to construction sites. Chinese engineers are trained to view challenges not as obstacles but as opportunities. The results prove how effective this approach is. By the end of 2024, China held over 3.5 million valid invention patents, with more than half already being used in industries. In many Western nations, patents often sit unused. In China, they are tools of progress. This scale and discipline have changed how fast the world builds. If a Western engineer estimates that a bridge will take 5 years, a Chinese team might say it can be done in 1 year and then deliver on that promise. In Chongqing, wide highways appear in the time it would take Los Angeles or London to debate the permits. Now imagine 1.5 million new engineers joining the workforce every year. Imagine a country producing more engineers annually than the population of entire European cities. Over 20 years, this becomes not just a workforce but a force of nature. But it's not only about numbers, it's also about focus. These engineers are directed toward solving massive problems, creating better machines, using artificial intelligence, advancing energy systems, and turning impossible goals into daily realities. While it might take the United States a decade to design and approve a new tunnel boring machine, China can design and build multiple models in the same period, improving each version and lowering costs through mass production. Back in 2008, when Beijing was preparing for the Olympics, China still depended on foreign-made tunnel boring machines. But by 2011, only 3 years later, it had produced its first homegrown model. By 2017, China was exporting its machines to more than 30 countries. Today, 7 out of 10 tunnel boring machines digging tunnels worldwide are made in China. And as if that dominance wasn't enough, China has also built machines unlike anything ever seen before, machines so advanced they seem to defy physics. These tunnel boring machines, designed and built entirely by Chinese engineers, can handle the most difficult conditions imaginable, from soft urban soil to earthquake-prone zones, while cutting tunnels faster and more safely than anyone thought possible. Some of these machines can dig up to 10 kilometers of tunnel in just one day, at a cost of about $10 million per kilometer, compared to the $50 million it usually costs in the United States. One remarkable example is the CRCHI-TBM, which completed one of the twin tunnels of the Zhensan East Road Highway beneath the Zhenjiang River in China. With a diameter of 15 meters, it ranks among the largest tunneling machines in the world. It has an output power of nearly 10,000 kilowatts, torque exceeding 42,000 Newton meters, and a digging speed of 50 millimeters per minute. This machine demonstrates not just the scale of Chinese engineering, but its precision and efficiency. Another example is the colossal Caucasian TBM, which has a diameter of over 15 meters, a total length of 182 meters, and weighs nearly 4,000 tons. It is one of the largest hard rock tunnel boring machines ever built. Its massive size allows it to move enormous amounts of rock quickly, completing tasks in weeks that would normally take months, while keeping the operation stable and safe. These machines use advanced slurry shield systems that help them work efficiently even in unstable ground. The system balances the pressure between the cutting chamber and the surrounding soil, preventing surface collapse and protecting buildings above. Hydraulic jacks and flexible joints allow the machines to adjust to shifting ground, while the slurry inside absorbs vibration, keeping the tunnels safe even in earthquake areas. These powerful machines are now driving some of China's most ambitious infrastructure projects. For example, on the Ningbo-Zhoushan high-speed rail line, the Jintang subsea tunnel is being dug using a 14.6-meter diameter machine weighing over 4,000 tons, the largest ever used for a subsea high-speed rail tunnel. In Guangzhou, another massive TBM, over 15 meters wide, dug the Haizhu Bay tunnel with minimal disruption to the busy city above, proving that Chinese engineers can combine great strength with delicate precision. Each TBM is equipped with intelligent control systems that constantly monitor torque, pressure, and ground conditions, automatically adjusting in real time to maintain speed and safety. These machines also use sensors and mapping systems that can detect changes in soil ahead of time, preventing accidents and improving accuracy. Some of the newest models, such as the Linghang TBM, are so advanced that they can be operated remotely, automatically adjust to difficult ground, and even monitor their own wear and tear. China's journey into this technology started in the early 2000s when the China Railway Group decided to design its own machines. At first, many people thought it was impossible. The chief engineer, Wang Dujian, recalled that at that time, most Chinese engineers had never even seen a tunnel boring machine in person. Each machine had more than 20,000 parts and over 2,000 control points, making it a huge challenge. But China's first independently developed TBM, called China Railway No. 1, was unveiled in 2008. The next year, it successfully completed a subway tunnel project in Tianjin in just 4 months, keeping ground movement to less than 3 millimeters, a remarkable result. From there, the domestic TBM industry grew rapidly, led by companies like China Railway Engineering Equipment Group, China Railway Construction Heavy Industry, and Tianhe Mechanical Equipment Manufacturing. A key breakthrough was the development of ultra-large main bearings, the heart of every TBM. These bearings must handle extreme pressure for long periods while maintaining reliability. Chinese engineers performed thousands of tests, experimented with hundreds of materials, and worked closely with steel companies to create bearings strong enough to support the largest TBMs in the world. In October 2023, CRCHI produced the world's largest main bearing, measuring 8.61 meters in diameter, the heaviest and most durable ever built. Modern Chinese TBMs have also become highly intelligent. They can monitor tool wear, temperature, and slurry pipe conditions, predict damage before it happens, and send live feedback to operators. This smart technology makes tunneling faster, safer, and more accurate than ever before. China hasn't just built massive machines, it has also achieved record-breaking construction feats. One of the most impressive examples happened in 2015, when the Mini Sky City project in Changsha stunned the world. The 50-story skyscraper was completed in only 19 days, about 3 floors a day. The building was made using prefabricated modular construction, meaning most parts were made off-site and then assembled like building blocks. This method saved time, reduced waste, and ensured top quality. Each of the 2,736 modules fit together perfectly, allowing the skyscraper to rise with astonishing speed. The project became a global example of how technology, planning, and precision can completely change construction timelines. Then, during the COVID-19 crisis in 2020, China showed its unmatched efficiency again by building the Huashanshan Hospital in Wuhan in just 10 days. This hospital became a symbol of what's possible when an entire nation works together with purpose and precision. From tunnels that cut through mountains to skyscrapers rising in days, China's combination of human discipline, machine power, and technological innovation has changed what the world believes is possible. These achievements have not only impressed engineers around the globe but have also redefined the meaning of speed, efficiency, and national strength. Through a focused strategy, massive education system, and unstoppable determination, China has turned what once seemed like science fiction into daily reality. In January 2020, China began building a 1,000-bed hospital during one of the most critical health emergencies in modern history. The construction started on January 23 and was completed by February 2, just 10 days later. This achievement stunned the world because it proved how quickly China could respond to a crisis with precise planning and advanced technology. The hospital's construction was based on prefabricated modular units, which meant that the foundation work and the building of individual modules happened at the same time. This saved enormous time and ensured that every unit was built under controlled conditions, reducing errors and delays. Thousands of workers, including engineers, electricians, and volunteers, worked around the clock in shifts. Over 7,000 people were on site, with cranes, trucks, and machines operating continuously. Every piece of material, from steel beams to hospital equipment, arrived exactly when needed thanks to perfect coordination between government departments, construction firms, and suppliers. China's strong industrial supply chains made this possible, showing how a country's speed and precision could redefine modern engineering. But China's innovation didn't stop with hospitals. The country's rise in global construction power has been fueled by a fleet of extraordinary machines capable of doing what once seemed impossible. One of the most fascinating examples is the SLJ 932, known as the Iron Monster. This massive bridge-building machine, designed by the Shiwang Railway Design Institute and built by the Beijing WOW Joint Machinery Company, is one of the largest bridge builders ever created. Measuring 91 meters long, 7 meters wide, and standing nearly 100 meters high, it weighs around 580 tons, heavier than some warships. Unlike regular cranes that lift small sections of bridges, the Iron Monster can lift entire bridge spans weighing up to 950 tons. It works by lifting a massive concrete beam under its frame, driving it to the edge of a pillar, and lowering it into place. Once that section is done, it moves forward and repeats the process, creating entire bridges span by span. The Iron Monster is not just big, it's incredibly mobile. It runs on 64 wheels grouped into fours, and each group can rotate 90 degrees, allowing it to move sideways with remarkable accuracy. Despite its size, It moves at a steady pace 8 km per hour when empty and 5 km per hour when carrying loads. Over its working life, one iron monster can construct between 700 and 1,000 bridge spans before being retired. It's mainly used for high-speed rail bridges that cross deep valleys and wide canyons, where traditional cranes and scaffolding would be too slow or dangerous. The machine's design combines lifting, carrying, and placing into one seamless process, which allows massive bridges to be built quickly and safely. Every component of the iron monster is designed with safety and strength in mind. It can carry loads much heavier than the trains that will eventually run across the bridges it builds. Teams of skilled operators control it with precision, even in extreme weather or dangerous conditions. Thanks to machines like this, China's high-speed rail network has expanded beyond 30,000 kilometers, the largest in the world. Decades of work in other countries can now be completed in just a few years. Western engineers once doubted such machines could work at all, but China proved them wrong. Another engineering masterpiece is the Kunlun, named after one of Asia's great mountain ranges. Developed by China Railway Construction Corporation, this machine lifts and positions massive box girders that weigh up to 1,000 tons. Kunlun is capable of performing the work of 3 traditional machines combined, even on steep slopes or curved tracks. It can install girders that are 24, 32, or 40 meters long and can handle uneven terrain, rivers, and mountains. What makes Kunlun especially impressive is its strength and agility. It's made from high-strength steel similar to that used in submarines and aircraft. In 2020, it completed its final heavy-duty test and then installed the first 1,000-ton girder for the Fujian-Xiamen high-speed railway bridge. This bridge stretched nearly 15 kilometers across the sea and was finished much faster than iconic projects like the Golden Gate Bridge. Kunlun's advanced systems make it one of the smartest construction machines ever built. It uses laser-based navigation for autonomous movement through tunnels, real-time monitoring systems to ensure precision, and automated placement technology to align girders perfectly. Operators can track everything from girder position to stress levels, improving safety and efficiency. These technologies reduce costs by 20% and speed up construction by 25%, allowing projects that once took years to be completed in months. It's also been tested in extreme environments like Chongqing's rugged landscapes, where 90% of the railway consists of bridges and tunnels. The machine has proven its ability to handle steep ramps, curved tracks, and tough conditions without losing accuracy or speed. If Kunlun dominates the mountains, another Chinese creation, the XCMG XGC 88,000 crawler crane, rules the skies. Built in 2013, this machine can lift an astonishing 4,000 tons, enough to hoist a fully loaded Airbus A380 airplane. The crane weighs over 5,300 tons and stretches 144 meters into the air. It's one of the largest mobile cranes ever built, surpassing even the famous cranes used by NASA. Powered by 3 Cummins engines that produce over 25,000 horsepower, the XGC 88,000 is both powerful and surprisingly mobile for its size. It consists of a main crane and a separate counterweight section that weighs nearly 3,000 tons on its own. The operator's cabin is as large as a small office, complete with air conditioning and space for multiple people. This crane is used in industries like nuclear power, petrochemical plants, and heavy industrial construction. It can lift entire building sections that weigh more than small houses, doing work that used to require multiple smaller cranes. Watching it operate is like seeing gravity defied. It moves enormous structures into place with smooth, controlled precision. Its boom can be adjusted for different heights and weights, making it one of the most versatile cranes in existence. Since it entered service, the XGC 88,000 has been used to build massive facilities that would have been impossible with traditional equipment. While the Iron Monster and Kunlun work on railways and bridges, another Chinese invention, the Pump King, dominates skyscraper construction. During the building of the Shanghai Tower, engineers faced a massive challenge: how to pump concrete nearly 2/3 of a kilometer into the air. Western pumps failed at such heights, but China's Pump King succeeded, pushing concrete 621 meters higher than the Eiffel Tower. It set a world record and became the Guinness World Record holder for the longest truck-mounted concrete boom. Its boom consists of 7 sections made from high-strength steel, giving it flexibility and stability. Mounted on a 9-axle all-terrain vehicle, the Pumpkin can move easily through crowded city areas. Its advanced control system allows one-touch deployment, automatic positioning, and vibration reduction, cutting shaking by 50% and boosting accuracy. The pump even detects over 150 types of malfunctions automatically, helping operators fix issues before they cause delays. This technology not only speeds up skyscraper construction but also makes it much safer. It was used on the Shanghai Tower project, pumping ultra-strong concrete to record heights, proving China's ability to build tall, fast, and efficiently. In railway construction, China also leads with the CYP 500 track-laying machine. This machine can lay 2 kilometers of track in a single day, an achievement that would take traditional teams days or even weeks. It operates non-stop, aligning and placing tracks with millimeter-level accuracy. The CYP 500 made its debut in Southeast Asia on the China-Laos Railway, where it quickly exceeded performance expectations. Its automated systems reduce downtime and ensure continuous operation, making it a symbol of China's push toward faster, more efficient railway expansion. Then comes one of the most remarkable machines for high-rise construction, the Bono. Standing over 40 meters tall and weighing nearly 2,000 tons, this machine climbs skyscrapers as they are being built. It can complete an entire floor in just 4 days, much faster than traditional construction methods. Unlike cranes that rely on scaffolding, the Bono has a self-supporting frame that lifts itself vertically after finishing each floor. Its advanced sensors monitor pressure, balance, and wind, making sure every component is aligned perfectly. It can even correct small errors automatically using its smart control system. The Bono's vertical climbing system is revolutionary. After completing one floor, it raises itself to the next level without being taken apart. Hydraulic jacks and counterweights keep it stable while sensors adjust for any wind or structure movement. Built from lightweight but extremely strong materials, the Bono can operate even in hurricane-level winds. It reduces the number of workers needed at dangerous heights, increasing safety and maintaining speed at the same time. Operators control it from a secure cabin where they can monitor every action in real time, ensuring that construction continues smoothly without interruption. Finally, to transport all these enormous machines around the world, China built the ingenuity, a massive semi-submersible vessel designed for heavy lifting and transportation. It can carry offshore wind turbines, prefabricated structures, and even smaller ships. Measuring more than 115 meters long, it has a deck area of 2,000 square meters capable of carrying up to 6,000 tons of cargo. Its design allows it to handle oversized and irregularly shaped objects, perfect for transporting components of bridges, skyscrapers, or wind farms. The ingenuity is equipped with advanced positioning systems, strong engines, and precise control mechanisms that let it operate safely even under rough sea conditions. It can anchor itself without tugboats and has an intelligent energy management system that optimizes power use, reduces fuel consumption, and predicts maintenance needs. This makes it not only powerful but also environmentally efficient. Its deck can be reconfigured to fit various types of cargo, from giant turbines to construction modules, and it's especially valuable for renewable energy projects and coastal infrastructure. Together, these machines show how China has redefined what's possible in modern engineering. From building hospitals in 10 days to lifting airplanes, climbing skyscrapers, and laying railways across mountains, every innovation pushes the limits of what humanity can achieve. These aren't just machines, they're symbols of human ingenuity, teamwork, and the power of technology to reshape the world.